Coming up on Destination Tomorrow, discover a new type of rover that may soon explore the Red Planet. Plus, learn about a robot that will assist astronauts in space. And our own Johnny Alonso finds out how telescopes work. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien. Welcome to Destination Tomorrow.
This program will uncover how past, present, and future research is creating today's knowledge to answer the questions and solve the challenges of tomorrow.
In recent years, there has been renewed public interest in the planet Mars. This increased awareness is due in large part to the success of the NASA rovers, which have been used to explore and unlock the mysteries of the Red Planet.
Although wheeled rovers and stationary landers have been successful, it's becoming apparent that more of the Martian surface needs to be explored to provide a better understanding of the chemistry of the surface and the atmosphere. Understanding these conditions will help prepare scientists and astronauts for future manned missions to Mars.
One idea now being studied for future Mars trips is a very simple but revolutionary type of rover called the Mars Tumbleweed. This ingenious new rover will not use engines, but will travel across the Martian surface with the help of the wind. I had the opportunity to speak with Jeff Antal at NASA Langley Research Center to find out more. For thousands of years, the planet Mars has triggered something in the human imagination. Generations of dreamers and scientists developed scientific theories about what they believe the surface of Mars would look like, what the atmosphere might consist of, and who might be living there. In 1976, many of these theories were answered when the Viking landers first touched down on the Martian surface. These landers found a very cold, desolate planet with no visible signs of life and a very thin atmosphere. Since then, NASA scientists have learned much more about the Red Planet. In fact, the United States has sent satellites to orbit the planet and small unmanned rovers to explore its surface. But with all that we've learned about Mars, unanswered questions still remain, such as, does life exist there? And has water ever flowed over its surface? Even though our satellites and rovers have provided a wealth of knowledge about Mars, limitations on their technology still remain. Satellites can only view the Martian surface down to about 1 kilometer, while the rovers can only travel a short distance from their landers. But a new type of rover being developed by NASA might soon provide us with a much better understanding of the Martian surface. Called the Mars Tumbleweed, this new rover is powered by the wind and has the potential to span a great distance over the surface of Mars, picking up scientific information as it goes. I spoke with Jeff Antal at NASA Langley Research Center to get a better understanding of how this new rover might work.
The Mars Tumbleweed is a concept for a new type of rover for exploring the surface of Mars. The conventional rovers use wheels driven by motors in order to move across the surface of Mars. The Tumbleweed would use the natural resource of the wind in order to be moved across the surface of Mars. It would be relatively inexpensive compared to the existing rovers and landers. However, that's fine because the Mars Tumbleweed is not meant to replace the existing rovers, but rather to complement the existing rovers. Conceivably, if they are less expensive, you could launch a large number of them, deploy them into a region, and have broader coverage of a region rather than just sending one rover.
How did you come up with this idea?
Well, the idea for using the wind to propel rovers across Mars has been around for some time, I believe since the early 70s. In 1997, Greg Hajos, the other principal investigator on the Mars Tumbleweed activity, he and I were discussing the Mars Pathfinder mission, and Pathfinder used an inflatable airbag system in order to land on the surface of Mars. So we were talking about how the airbag system and Pathfinder must have bounced and rolled a considerable distance before coming to a stop, and then deflating the airbags and the Sojourner rover deploying and only traveling a few meters. So we thought, would it be possible to continue the rolling as the airbag system was doing? Could you travel greater distances using that method rather than just a small rover? And would it be possible to use the winds to do that, much like a tumbleweed plant does here on Earth? A great analogy to this is comparison between a powerboat and a sailboat here on Earth, where a motorboat is limited in the distance it can travel by the amount of fuel it can carry. A traditional rover is limited by the battery and its power source. The tumbleweed is similar to a sailboat in that it uses the natural resources of the wind and therefore can travel greater distances and perhaps travel to greater areas on Mars.
Once on the ground, the tumbleweed will be able to start collecting data almost immediately. As the wind begins to blow, the tumbleweed will move across the Martian surface, traversing many miles in a short period of time. Once the wind stops blowing, the tumbleweed will stop and activate its scientific instruments, such as water-seeking radar, cameras, and other instruments that will search for signs of possible life. Once the wind begins to blow again, the rover will tumble to another location. As long as the wind continues to blow, the rover will be able to continue its journey across Mars. However, using the winds on Mars to move a rover is not a minor task. Because the Martian atmosphere is very thin, even the strongest winds would feel just like a gentle breeze here on Earth. Can you describe the various tumbleweed rover concepts?
There are two basic types of tumbleweeds that are currently being investigated. Inflatable beach ball type tumbleweeds are being examined by the Jet Propulsion Laboratory. We at NASA Langley Research Center are looking at non-inflatable tumbleweeds.
Both types of rovers would be about 25 feet in diameter, or about 2 stories high, but their designs would be somewhat different. The inflatable rover would look much like a beach ball made of a very tough, tear-resistant material. Of the proposed non-inflatable rovers, the shapes vary from a dandelion shape with foot pads to a box kite shape rover with sails. All of these designs would be lightweight and durable, allowing them to be easily driven by the Martian wind. Researchers here on Earth must now decide which shape would be the best platform for scientific instruments. Can you describe what type of science will be conducted by the rover?
There's a number of areas of science that we're currently investigating, anything from monitoring the weather to doing geological investigations to even searching for water or life on Mars. In order to monitor the weather, we may have it carry a number of pressure or temperature type sensors. Searching for life, you'd have some monitors for detecting water. Perhaps you could drop off sensors as the tumbleweed rolls in order to study the surface or to study the soil composition.
So, will the rover be controlled from Earth, or will you just let it go wherever the wind pushes it?
Actually, the initial concept for the tumbleweed, the first generation tumbleweed, would be entirely at the mercy of the winds. So it would go just wherever the winds push it. However, we've discussed a number of concepts for being able to add some control capability to the tumbleweed so that you could either stop it at a particular location of interest and start it again, or perhaps steer it in a particular direction and to go to particular areas that might be of interest. But even with the passive tumbleweed, you would have some starting and stopping depending upon when the winds are blowing and when they're not blowing. If the passive tumbleweed would even get blown into a canyon or a ravine and get stuck there, hopefully the sensors would still be operational and you'd still be able to communicate that data back to Earth, so you'd still have a functioning station.
What do you hope that NASA can learn from this rover?
We're hoping that the Mars tumbleweed will provide a new capability to go to regions on Mars that perhaps are not accessible by current types of vehicles, as I said, within canyons and craters and such. We hope that we'll be able to provide this capability at a lower cost and to provide, conceivably, a number of these could be sent at one time, covering broad areas and traveling longer distances than traditional rovers. And so these would act as scouts for other follow-on missions, perhaps more advanced landers or even human explorers.
NASA is not the only agency sending spacecraft to Mars. The European, Japanese, and Russian space agencies have all sent spacecraft there in recent years, with mixed results. Coming up, we'll discover how a new robot developed at NASA will assist astronauts in space. But first, did you know that Mars resembles Earth more than any other planet in our solar system? Due to the tilt of the planets, both Mars and Earth have 4 distinct seasons. However, this is where the similarities end. The Martian atmosphere is unsuitable for humans, containing about 95% carbon dioxide and no oxygen, with ground temperatures on Mars reaching as low as minus 193 degrees below zero.
Since the mid-1970s, manned space travel has been relegated to relatively short flights close to Earth's orbit. But with the push for manned travel to Mars and back to the Moon, researchers will need to make improvements in the development of systems and technologies related to spaceflight. With these new developments, the job of an astronaut will become much more complex. In addition to the necessary tasks astronauts need to perform on a daily basis, there will be a much greater learning curve to accomplish all the mission's goals. With this problem in mind, researchers at NASA have developed a new type of robot called the Personal Satellite Assistant, or PSA.
This robot will help astronauts perform their tasks while freeing up precious time for other activities. Jennifer Pulley traveled to NASA Ames Research Center to find out more.
An astronaut's job can be incredibly demanding. In most cases, it takes years of specialized training to learn all the skills that will be used aboard the shuttle or on the International Space Station. So with all that an astronaut must learn and accomplish to get to space, it's not surprising that only the best and brightest are chosen to fly. In addition to the specific jobs astronauts are trained to perform, there are also many more mundane yet still important tasks that must be completed every day. Some of these tasks include monitoring environmental conditions in a spacecraft, such as the amount of oxygen, carbon dioxide, and other gases in the air, or just running routine checks on systems. Because these tasks must be performed every day, valuable time is lost trying to accomplish more of the mission's goals. With this problem in mind, researchers at NASA are developing a new device that could give astronauts additional time to complete mission goals. The Personal Satellite Assistant, or PSA, is a robot that could soon be helping astronauts by performing some of their more mundane tasks, thereby increasing crew productivity. I spoke with Dan Andrews at the NASA Ames Research Center to find out how the PSA works and how it will benefit astronauts.
The PSA stands for the Personal Satellite Assistant, and it's a type of robot that is intelligent and a free flyer to go aboard the ISS, a shuttle, or any spacecraft at all. It will fly around and it will be helping the astronaut on a number of easy or complex tasks. It can simply be a video recorder that records what he's doing. It could be a PDA that allows him to see what his tasks are for the day. The PSA can provide crew support as well as help to decrease system risk on a mission. The way it decreases system risk is to work with the environmental control system aboard the station or the spacecraft in general and help to diagnose faults and even rectify them. An astronaut will frequently be occupied doing some activity that will prevent him from being able to physically interact with a laptop or a PSA. And so the PSA is equipped with voice recognition software. The software will be able to understand the spoken words of the astronaut, convert them into text, and then enact what he is requesting of the PSA. For example, he can tell the PSA, please go down to rack 19 and check the temperature over there, because perhaps a sensor is indicating that it's getting hot over there. Maybe something's going wrong. The PSA would then parse that command into individual words, understand it, process it, go head out to that hot rack, and then take a temperature measurement, and then report back, also in spoken word by way of voice synthesis software, what it discovered.
How does this device propel itself or move around the station?
Most spacecraft or satellites propel themselves by using compressed gas that is stored within the body of the vehicle. In the case of the PSA, because it is operating inside of the station, in and around crew members, we thought it would be better to use fans or blowers as the propulsion means. In our first propulsion testbed, we used axial fans for what we're attempting to do. However, in the long run, axial fans do not work very well. This propulsion system has evolved from the propulsion system of its predecessor. This one employs a blower-based system. Instead of a series of 6 fan units, which the previous PSA uses, this uses 2 blowers, one located on top and one located on bottom. What they do is inhale air through these vents on the sides, 4 sides over here, and then exhale the air in a controlled fashion in order to get the PSA to move in and out, up and down, even perform rotational movements.
In addition to its assistance to the crew on board, controllers on the ground will also be able to command the PSA remotely, being able to monitor onboard systems while not bothering the crew. Another key benefit of the design would be the ability to have several PSAs conduct collaborative environmental troubleshooting activities. In order to accomplish this, several PSAs would use formation flying techniques to zero in on a problem, such as a pressure leak or temperature spike. This technique would allow these flying assistants to check out potentially dangerous areas while not endangering the human crew. I understand how the PSA will propel itself, but how will it know where it's going?
The PSA at first is going to work in an engineered environment. And what I mean by that is we're going to put different visual cues in the space of our test facility here. And the PSA will then be able to look through its navigational cameras at those visual cues and deduce where it's at. Ultimately, we would like the PSA to be able to self-localize. And so what that means is it is not depending on an engineered environment in order to operate. It has an internal map within the PSA that it compares against features that are seen within the environment, and then it can figure out where it's at.
Explain why these two PSAs are different sizes.
The model that we have behind us is a working prototype that let us check out technologies, allowed us to use easy-to-get, off-the-shelf components in order to get going on the effort. But ultimately, the 12-inch diameter of that prototype is not practical for interacting with humans in a small space. We envision this size, which is about 8 inches in diameter, being a more practical, feasible size.
Sure, now explain to me, I see it looks like a television screen.
Exactly, this is an LCD screen. Think of it as like a small computer screen. And on here we can display everything from video images, still images, text, schematics, anything that you would normally be able to watch on your own computer, but in the interest of aiding an astronaut in some function that he's doing.
Tell me about the cameras on the PSA.
The PSA in this version employs a series of cameras for both navigation and teleconferencing capabilities. You see some of the navigation cameras down here, one on each side, and a pair in the back. We also have a teleconferencing camera capability which is located right above the screen. So in effect, when you are looking at the PSA, what you're really looking at is perhaps a researcher on Earth. You see her image in the screen, she sees your image, and it fosters a really good dialogue even though you're very, very far away from each other. What's really cool about working on the PSA is it's allowing us to further technology into intelligent robotics that will ultimately become very standard on future spacecraft of all types. I fully expect that robots will become the onboard technicians and specialists that'll keep the vehicle, the space vehicle, operating and healthy. This allows the astronauts to go about their work in a safer environment with less drains on their time so that they could focus on the work that they were sent up there to do.
First generation prototype of the PSA, called the Wireless Network Experiment, or WNE, first flew in space aboard the shuttle in 1995. Coming up, we find out exactly how telescopes work. But first, did you know that the first true laptop computer was flown aboard the space shuttle in 1983? Called the SPOC, or Shuttle Portable Onboard Computer. This computer was adapted from the Grid Compass computer. Since the shuttle's main computers must handle a multitude of processing functions, NASA wanted a separate portable computer which could provide reliable monitoring of the craft's orbital path and a visual display of its position at any time. This portable computer proved so successful that laptops have been flown on shuttle missions ever since.
Before the early 1600s, astronomers had few reliable means to study the stars and planets of our solar system. They depended on inaccurate tools that could not properly observe the cosmos. This all changed with the development of a new device called the telescope.
Today, the telescope is one of the most recognizable tools used by professional and amateur astronomers alike. Although they have dramatically improved since the 1600s, the basic design remains the same. But even though telescopes have been around for hundreds of years, people still don't know exactly how they work.
Johnny Alonso spoke with Dr. David Gilman to find out how these important devices are being used to further our knowledge of the universe.
The telescope is without doubt one of the most important scientific tools ever created. With its introduction, observers for the first time had the ability to see astronomical sights like planets and moons with much more clarity. This single device helped to start the so-called scientific revolution of the 17th century, which helped dispel many of the incorrect scientific beliefs of the time. The great scientist Galileo is credited with being the first person to use a telescope for scientific research in astronomy. With his improvements on the design of the telescope in 1609, he was able to begin making astronomical findings that would change our understanding of our place in the universe. The scientific revolution had begun, pushed forward by the telescope. Telescopes changed very little until the late 1670s, when Sir Isaac Newton designed the first reflecting telescope that used mirrors, rather than an optical lens used in Galileo's refracting telescope. This new type of telescope once again changed the way that scientists observed our universe. Although telescope designs have obviously become much more advanced since the time of Galileo and Newton, the basic principle of how they work hasn't changed. I spoke with Dr. David Gilman from NASA Langley Research Center to talk about telescopes and find out how they work.
Well, a lot of people think that telescopes are used to magnify the image of the sky, but actually, for astronomers, that's not how they use telescopes. They're used in two ways in astronomy, and the first way is really just to gather light. Some stars are very faint things. You can't even see them with your naked eye. And they have to gather a lot of light so that their instruments can maybe tell something about it from its color or from how it changes brightness over time. This takes a lot of light for something that might be halfway across the universe. The other thing that astronomers use telescopes for is to get an image of what is going on around the object of interest. It might be a spiral galaxy, or it might be remains of an exploded star, in order to see how the pieces are related and affect each other. And here, magnification can make a difference, but normally that's not the principal characteristic people are looking for in telescopes.
Can you explain to me the different types of telescopes?
Although you can make telescopes of any combination and call it a compound telescope, primarily there are two types. The first type of telescope is a refractor telescope, and it's made of lenses, and you kind of see its image when you see a pirate holding a spyglass to his eye. That's a refractor telescope.
Yes.
But principally, astronomers use reflecting telescopes. They have these big curved mirrors to gather the light and create the image.
Understanding how a telescope works is simple if you think about it like this. Everything that humans can see is brought to the eyes by light. A telescope is very simply a device that can gather much more light than the human eye can alone. In a refracting telescope, it gathers light with a large lens called the objective lens, while the reflecting telescope gathers light using a primary mirror. Although both types of telescopes accomplish the goal of collecting light, they do it in different ways. In a refracting telescope, the objective lens is located at the top of the structure. This large lens collects the light, then directs it to the focal point inside the telescope. On the other end of the telescope, a small eyepiece lens then brings the image from the focal point to your eye's pupil. This type of telescope works well with smaller telescopes, but making large glass lenses to exacting standards can be difficult. Because it is relatively easy to make large mirrors, most of the telescopes used for scientific measurements are reflecting telescopes. The reflecting telescope works by collecting a large amount of light onto its primary mirror. It then reflects the light back up to a secondary mirror that is angled to reflect the light into an eyepiece. Now, the eyepiece is key for both types of telescopes because magnifying lenses are embedded inside, allowing the image to be easily seen. The larger the lens or mirror in the telescope, the more light that can be gathered, providing a very bright, detailed image of the cosmos. I know that we have ground-based telescopes. Why do we need telescopes in space like the Hubble?
Well, space is really the ideal environment for a telescope. It turns out that if you look at a telescope and look at a star and magnify it as much as you can, all you see is a big, fat, blurry dot, all because of the turbulence in the atmosphere. But in space, that is gone. And we can make telescopes that can have image quality of 1,000 times better, in principle, 1,000,000 times better.
Wow.
And with that, we can see down into the hearts of galaxies and find out what's going on to make some of them active and some of them exploding and many of the other things that we're interested in. So that's one reason to go into outer space. The other reason to go into outer space is that if you're on the ground, you're limited to what the air will let through. It turns out that as you go towards the ultraviolet, the ozone blocks it. That's a good thing because we don't want to get burned with ultraviolet light from the sun.
Sure.
But it's a bad thing when you're trying to find out about the ultraviolet light from stars. There's only a relatively narrow, what we call a window, that is, you can see through the atmosphere, which extends somewhat from the infrared to somewhat in the ultraviolet. But to really explore the entire spectrum of electromagnetic radiation, you have to be in space.
You sometimes hear that telescopes can look back in time to the beginning of the universe. Can you explain that to me?
Well, it's a little bit like the way we hear sounds that were created a little while ago. Sometimes you can see that if you see somebody practicing tennis at a distance, you'll see the ball. And a little later, maybe a second later, hear the bang. And same thing happens with light. It turns out that the light from the moon takes a little bit longer than 1 second to get here, so you're looking back approximately 1 light second when you look at the moon. When you look at the sun, that light left 8.5 minutes ago or so. If you look out at the nearest star, the Alpha Centauri, well, that's like 3 years ago since that light left. It's just only has a certain maximum speed. And so you're always looking back in time when you are seeing even you. It's a little bit back in time.
You're freaking me out. So, Dr. Gilman, do you think that telescopes have reached their limits?
Telescopes have a lot more work left to do. Now that we have completed Hubble and are moving into the next generation of telescopes like the James Webb Space Telescope, we expect to explore the universe in the infrared. Just as the atmosphere here on Earth blocks what we can see, so there are grains in the space between the stars, small particles the size of smoke particles, that block the light coming to us from stars. Infrared light gets through it. So the next round of telescopes are going to exploit this window of visibility in the universe around us. NASA is really leading this exploration. It is a great endeavor of discovery that is going to lead us to the edges of the universe and find out about these forces and what makes the universe the way it is.
So that's how it works. So the next time you want to look out into the universe, reach for your nearest telescope and check out some heavenly bodies.
That's all for this edition of Destination Tomorrow. Thanks for joining us. I'm Steele McGonigal.
And I'm Kara O'Brien. For all of us here at NASA, we'll see you next time.